A very good afternoon to you. I'm Kelly Cohen, this is Andrew Shepard, and Terry from Demeter. We're going to talk about this joint project with it's an academic as well as an industry partnership. We're two academic institutions, Sinclair and the University of Cincinnati, and two industries, one a US-based industry, Demeter, and the other industry is based here in Israel, that's Simlat. So a bit of a background on the unmanned traffic management system and the vision itself. You could see here several use cases. This is the NASA's concept for a UTM. You can see a search and rescue, sports coverage, traffic monitoring, fire service, agriculture, and a couple of others all put into one. The idea here is collaboration. So as opposed to some of the talks here that was on threats, here we're looking at several use cases, sharing one airspace, and how do we coordinate all that activity. So when they speak about UTM in the United States, we're talking about something which is complementary to FAA's air traffic management system, or the ATM. The vision is, how does the airspace be managed to enable many drone operations in several areas at the same time, conducted beyond the visual line of sight, where air traffic services are not provided, what is called the uncontrolled airspace. And as of February of 2019, earlier this year, there were 1.3 million registered drones in the United States and more than 116,000 registered drone operations. There is a feeling that there are hundreds of thousands of additional drones that are not registered. So having to coordinate all of that is a huge challenge. But there is a huge demand by the industry, by the services to include drone operations. And so having to come up with a structured approach to solve the problem is crucial. NASA's concept for this unmanned traffic management system is safely manage these diverse US operations. So you can see here a couple of layers. There is the layer above 400 feet where manned aircraft fly, and there is the tops of the buildings. So we're talking about having to work in this uncontrolled airspace between the tops of the buildings and 400 feet in both suburban as well as urban areas. Now, the main attributes of the UTM is that you don't want one human operator to monitor every vehicle continuously. That is not feasible. What we want to do is to provide human managers the data to make these strategic decisions on airspace operations, and this approach would ensure that only authenticated US would operate in the airspace. There are two types of possibilities, either a persistent system, which is well-based, and a portable system. Main challenges, basically safety. That's the whole idea. Getting them all working together, providing important services in the very different use cases simultaneously while having safe operations. So we need to define these definitions. There are different companies, each one is very diverse, developing different technologies. How do we get that working together? We want to have solutions that are fair, allowing equitable access to this airspace. So right now, I'll present the different components of the team here. You can see the four partners and what each of us are doing. This is a good example of a US-funded operation, a joint collaboration between Israeli academic and industry and that of Israel, doing a couple of things. The project is called a Regional Unmanned Traffic Management System. We competed and we won. That's why we're here. It's an 18-month program. It's worth about $2 million with the 50% cost share included in that. And it allows us to create a capability that we would then want to commercialize. So Terry will come here and talk about the project itself. Terry, you can go down. Yes.
This is the architecture of the system. You see at the top there, GBSAA, a ground-based sense and avoid. The system is working on a UAS range that's being prepared to enable beyond visual line of sight and actually has FAA authorization for that. And it takes in feeds from the radars, FAA radars, and that provides that. The challenge we face is that all these systems that are used in drones were developed in a proprietary sense often and developed by different developers. So to the left portion of the screen is our universal translator portion. And the universal translator has two components. It has a set of protocols designed to ingest into the system, and then it has modules for each specific drone. And that module could be as simple, if there's enough onboard processing power, to be a software patch that gives the outputs that the system can read, or it can be a tiny little module that gives the outputs the system can read. The potential impact for our federal stakeholders, and this is really the advantage of this funding in the state of Ohio, is nearly $100 million worth of defense and NASA expenditures are made in Ohio each year. And then Ohio has added this system, which makes funding available to, we'll say, not just American companies, but Israeli companies, close allies. And these projects align with needs, military research needs that are useful. And so you see, when we develop this, these are the kinds of benefits those federal stakeholders have. You see what our milestones are to demonstrate the translator and associated software, test the integration of the software, and we're going to tailor these demonstrations for a disaster response scenario. And here's a few, the Air Force Research Laboratory, some of the benefits they receive. SkyVision is that ground-based sense and avoid system that takes UAS radars, integrates it from these now translated and self-reporting UAVs, and then displays it together in a management system. Dr. Shepard?
Thank you. So a little bit about the project in progress, and I'm going to go through these slides quickly to get to a video. But we've been working on the Universal Translator project for a while now. They've integrated several different protocols and brands of autopilot into the translator. One thing Sinclair has been doing is providing flight telemetry. So we've been flying in various just testing environments, but also live world environments where we've been providing that for development of the translator and then testing. And now most recently we've been moving into actually on airport integrated testing with the team. So I'm going to just move through these here quickly. But the idea is that this is able to feed into a system that you just heard mentioned called SkyVision, among other things. And SkyVision is what we were able to use to leverage a beyond visual line of sight flight operation, which is the video that's now playing. This occurred in April of this year. Why was this a big deal? You've heard about BVLS, or Beyond Visual Line of Sight, before. This was a COA, a Certificate of Authorization issued to the Air Force Research Lab for operations over about 200 square miles in southwest Ohio. And this is an unsegregated airspace. So we were operating, launching here out of an airport. There were live manned aircraft operations happening at the same time as the flight. We're flying a Group 2, what we would call Group 2 UAS. And so there were small Cessnas and corporate jets flying in and out of the traffic area. And they were aware of our presence, but they weren't asked to vector or alter any of their operations. We were updated about what was happening through the SkyVision system and the ability to bring in that telemetry. And all this was facilitated by an agreement of the Ohio Federal Research Network with the Air Force Research Lab and operated underneath the project that's led by the University of Cincinnati, and in this case flown and executed by Sinclair. And so when we were doing the operation, we had a STARS radar scope basically set up, being ingested from air traffic control. There was an air traffic controller on field that was monitoring the airspace and what was happening, but the telemetry from the Piccolo autopilot in that case was being ingested into the environment and then overlaid on the radar scope, connected up through fiber out on the field. So you can see that's our ground control station as we were getting set up there, and we were able to pull this off in actually 13 days from the call from the Air Force Research Lab. They contacted us and said, we need you to do this. The governor has a deadline, and so we had to go through the Air Force Flight Safety Review Board, the Airworthiness Review Board, go through the reviews and sign-offs at all levels that are normally required for that. And then this was the first execution of that COA. So this wasn't just the first time our team flew it or that Sinclair flew it. The Air Force hadn't even flown their COA yet, so we were able to do that for AFRL. So you could see the rest of the video if you'd like later, but basically this was a success. It was enabled by the project, enabled by Ohio for Research Network, and it ties in certainly with the Translator project. So back to Kelly for any closing thoughts.
There are several opportunities to work together, and we've just shown how academia as well as Israeli companies could work together and get funding and develop products which are meaningful and get them proven. Thank you very much.